Alright, this video is to help you understand Pythagorean Theorem, which is a squared plus b squared equals c squared. You can use it to find any side on a right triangle as long as you know the other two. So, how it works. A and B are the legs of the right triangle. Doesn't matter which one's A or B, you can tell where they're located because they always meet right here where the right angle is. The other side, side C, is always going to be the hypotenuse. Something important to know about the hypotenuse is that it is the longest side on the right triangle. In addition to that, you can find it because it is located across from the 90-degree angle. So to use Pythagorean Theorem down here in example 1, you will notice that we know two sides and we're attempting to find the third. This side is the hypotenuse, which means it has to be the longest side on the right triangle. So when we're all done finding it, we have to make sure it is bigger than 13. So to use Pythagorean Theorem, I'm going to start out with the equation that says a squared plus b squared equals c squared. If we plug in what we know, x is the c value, and then a and b are 12 and 13. So here we're going to have 12 squared plus 13 squared needs to equal x squared. So first thing I'm going to do is I'm going to pop up a calculator and calculate 12 squared plus 13 squared and find out that that equals 313. So back here, this is 313, and that is what x squared equals. In order to solve for x, what I'm going to do is I'm going to square root the 313. This will give me my value for x. So if I jump back to that calculator and I go over to the square root button, I can square root 313, turns into 17.7. So we just found out that x is approximately 17.7. I like this answer. It makes sense because it would make the longest length on the right triangle as it's supposed to be. If we try example 2, you will notice in example 2 that we already have the hypotenuse. So what that means is this side length x, it must be smaller than 16. So when we use Pythagorean Theorem, we have to make sure our answer is definitely less than 16, or else we will have messed up and done something wrong. So if I start Pythagorean Theorem on this, I'm going to start out the exact same way. The formula is a squared plus b squared equals c squared. If I plug in my pieces, 16, my hypotenuse needs to go over here. And then a and the b are the 12 and the x, so I'm going to put the 12 squared here, plus x squared there. So now at the moment I have an equation. I'm going to calculate what 12 squared is. I know that 12 squared is 144. And on this side I'm still going to have the plus x squared. And then I'm going to calculate what 16 squared is. I know 16 squared is 256. So now I'm going to keep solving the equation. If I subtract 144 from both sides, subtract 144 over here, I find out that x squared is equal to 112. So in order to solve for x, I'm going to go back to my calculator, and I'm going to type in the square root of 112, and I'm going to find out that the answer is approximately 10.6. So what I've just discovered is that x in this problem is about 10.6. Again, I like this answer because it is definitely smaller than 16, like it should be. So an application of this problem is something like example 3 down here. In example 3, you can see that we are attempting to find the perimeter of the largest triangle, which means I'm going to have to add up all 3 sides. If I take a look at what I know so far, the distance from here to here is going to be 6, because I can use that 3 for both 3 here and over here. If I keep looking, I notice that this triangle inside the big triangle is actually a right triangle. If the height is 4, right there, and this piece down here is 3, I can actually use those two lengths in order to find out this other length over here, which I'm going to need for the perimeter of the biggest triangle. So I'm just going to take this chunk of it and slide it over here so you can see it as a separate triangle. And what I'm going to do is I'm going to use Pythagorean Theorem again to find the length of x. Keep in mind x is the hypotenuse, so it has to be bigger than 4 because it's along the side. So if I set up with Pythagorean Theorem, my a and my b are 3 and 4, so I'm going to do 3 squared plus 4 squared. That will have to equal the hypotenuse squared, which is x, so I'm going to put x squared. If I calculate 3 squared plus 4 squared, that becomes 25. Over here, now I have 25 is equal to x squared. I can solve this by square rooting the 25, which turns out that x will equal 5. So at this moment, I've just discovered that this length is 5. So if I put a 5 right there instead, and then I take that and I place it back, actually I'm going to erase the 4 and the 3 first. If I put that back on the original picture, oops, should get rid of that too. Back on the original picture, I now know that this length is 5, which if that length is 5, and I've got the markings indicating that they are the same length, that means this length is 5. So if I want the perimeter of the entire triangle, I get perimeter by adding up all 3 sides, so it's going to be 5 plus 5 plus 6, for a final answer of 16, or maybe 16 units, just because it's perimeter. Hope this helps.